All right, let's look at the surface areas. All right, let's say you have a surface in three-dimensional space. Its equation is f of x comma y comma z equals c. All right, then we have let's say a region in the xy plane, and then that's the projection of the region that we're interested in. So we're trying to find the area on this region on the surface over this region on the xy plane, right? So this area here, this is what we're interested in, right? So in order to find the area, so area A is going to be, I guess it's a two-dimensional space, so it makes sense to have a double integral. And over this region in xy plane, so I'm gonna just say R here. Then of area element, so we have to find out what the area element is for this surface, right? So in order to find the area element, we're gonna kind of look at the small, tiny space, tiny square or box, dx by dy. And then we're going to look at the corresponding image on the surface. Right, so you would have something like this up here. Right. So to make our lives easier, this a little piece on the surface is going to be a little bit tilted. So tilting by a certain angle expands the area by a certain amount. So for example, so I blew this up into so bigger picture here. So you have a dx by dy rectangle there. Then let's say we tilt this by angle gamma or something like that. So this angle will be gamma, right? Then what happens is, let's say I'm gonna tilt it so that the dx doesn't change, but the dy is gonna be a little bit longer. So let's say here, how long is this, right? So we know that the cosine of gamma, right? Cosine is let's say adjacent, so it's a dy over hypotenuse, so it's going to be this is what we're looking for, right? So we know that what you're looking for is, I guess you take the reciprocal of both sides, and so you have a 1 over cosine of gamma is secant is question mark over dy. Then you can multiply through by dy to get the question mark is really the same thing as secant of gamma dy, right? So if we are interested in the area here, the difference is dx in this case stays the same, and here this side is going to be a little bit longer, so you multiply by secant of gamma, right? So the area element is going to be, right, secant of gamma dy, or actually I'm going to put the dy here, times dx will give us the area of this this part, tilted part. All right. So if you can find this gamma at every single point, then we should be able to find this area here, right? So the next question is, how do you find secant of gamma, right? So secant of gamma, so if you can find the normal vector here to the surface, and remember that the normal vector can be found by looking at the gradient, right? Then also we have a vector going straight up, so let's use the vector, so in the z direction, so it's a vector k. Vector k is simply 0, 0, 1. It's a unit length and pointing straight up, right? then you can see that the angle the gradient of f makes with the k vector, that's actually is going to be same as gamma, right? So we can find that gamma by doing this, right? So let's just try to find the cosine of gamma, right? So cosine of gamma is equal to, right, you have two vectors, so you take the dot product of each other, then divide by the magnitude of each vector, right? But here we know that this is a unit vector, so this is equal to, this is equal to 1, right? Then so we're not going to write that. So, and the gradient is a partial of f with respect to x, comma partial of f with respect to y, comma partial of f with respect to z. And you take the dot product with k, which is 0, 0, 1, and all over, and this is 1, so you just get that magnitude of gradient of f, right? So if you compute that, this times that is 0 plus partial of f with respect to z over magnitude of gradient of f, right? So if you take the reciprocal of both sides, then you can get the secant of gamma, which is going to be just the magnitude of gradient of f divided by partial of f with respect to z, right? So we can write this guy as integral over this R, region R, and the secant is just the gradient of f over partial of f with respect to z, dx, dy, right? So that will give us the surface area, right, in general form. And in the next video, I'm gonna look at the particular example, and we're gonna pick a nice example where secant of gamma is pretty simple, right? That's it. I hope that this was clear.